Hardwired uninterruptible power supply, or UPS, systems can provide backup power to numerous outlets for sensitive equipment. Several manufacturers offer hardwired UPS solutions, including APC by Schneider Electric Power Structure, Eaton Powerware, Vertiv Liebert EXM, and Cyber Power Systems. These UPS systems can be found for purchase at various distributors such as Grainger, Newark, Allied Electronics, Mouser Electronics, and DigiKey. Hardwiring a UPS at the panel board location to feed circuits to different areas is indeed possible, but it's crucial to understand the process and safety considerations involved. This type of installation requires professional electrical expertise. The general steps involved are, firstly, determining the power requirements of the equipment you need to protect. This involves calculating the total wattage or volt amps the equipment draws under normal operation. Secondly, select a UPS with sufficient capacity and features. The UPS should have a power rating, measured in volt amps or watts, that exceeds the total power requirements of the connected equipment. Consider features such as surge protection, voltage regulation, and battery runtime. Thirdly, install the UPS in a suitable location near the panel board. The location should be dry, well ventilated, and easily accessible for maintenance. Ensure the UPS is mounted securely and according to the manufacturer's instructions. Fourthly, disconnect the main power supply at the panel board. This is a critical safety step. Before working on the electrical panel, turn off the main breaker to de-energize the entire panel. Use a voltage tester to confirm that the power is off. Fifthly, connect the UPS to the panel board using a transfer switch. A transfer switch allows you to switch between the main power supply and the UPS power supply. This ensures a seamless transition during a power outage. The transfer switch should be rated for the appropriate voltage and amperage. Sixthly, reconnect the main power supply and configure the UPS settings. After connecting the UPS and transfer switch, turn the main breaker back on. Configure the UPS settings according to the manufacturer's instructions. This may involve setting the voltage, frequency, and battery parameters. Seventhly, run dedicated circuits from the UPS to the outlets in the desired areas. These circuits should be sized appropriately for the load they will carry. Use the correct gauge wire and install appropriate circuit breakers in the panel board. All wiring must comply with local electrical codes. Important notes to consider are that hardwiring a UPS is a complex task and should only be performed by a qualified electrician. Working with electrical systems can be dangerous, and incorrect wiring can result in electric shock, fire, or equipment damage. It's also important to ensure that the electrical wiring meets built-in codes and safety regulations. Built-in codes are designed to ensure the safety of electrical installations. A qualified electrician will be familiar with these codes and can ensure that the wiring is done correctly. Always follow the manufacturer's instructions for safe installation and operation. The manufacturer's instructions provide specific guidance on how to install and operate the UPS safely. Carefully read and follow these instructions to avoid damage to the equipment or injury. Selecting the correct size UPS is crucial. The size of the UPS depends on the power requirements of the equipment being protected and the desired runtime during a power outage. To determine the appropriate size, calculate the total power consumption of all connected devices in watts or volt amps. Add a safety margin of 20 to 25% to account for potential future expansion or fluctuations in power demand. Select a UPS with a power rating equal to or greater than this value. The runtime of a UPS is the amount of time it can provide backup power during an outage. This depends on the battery capacity of the UPS and the power draw of the connected equipment. The UPS runtime is typically specified in minutes at different load levels. Determine the minimum runtime required based on how long you need to keep the equipment running during a power outage. For critical applications, consider a UPS with a longer runtime or the ability to add external battery packs for extended backup power. Different types of UPS systems exist, such as standby UPS, line interactive UPS, and double conversion UPS. Standby UPS systems are the most basic type. During normal operation, the connected equipment is powered directly from the incoming utility power. When a power outage occurs, the UPS switches to battery power. This switchover can take a few milliseconds, which may not be suitable for sensitive equipment that cannot tolerate any interruption. Line interactive UPS systems regulate voltage fluctuations and provide surge protection. They use an automatic voltage regulator, or AVR, to stabilize the voltage supplied to the connected equipment. During a power outage, the UPS switches to battery power. The switchover time is typically faster than standby UPS systems. Double conversion UPS systems provide the highest level of power protection. They continuously convert incoming AC power to DC power and then back to AC power. This isolates the connected equipment from any power disturbances, such as voltage fluctuations, frequency variations, and harmonic distortion. During a power outage, there is no switchover time, as the equipment is already running on battery power. This type of UPS is ideal for critical applications where even a brief interruption is unacceptable. Consider the input and output voltage requirements. Ensure that the UPS is compatible with the voltage requirements of the equipment being protected and the available power supply. Common voltage configurations include 120 volts, 208 volts, and 240 volts. Select a UPS with the appropriate input and output voltage ratings. Some UPS systems offer features such as remote monitoring and management. These features allow you to monitor the status of the UPS, receive alerts when a power outage occurs, and remotely manage the UPS settings. This can be particularly useful for managing UPS systems in remote locations or data centers. Check for safety certifications like Underwriters Laboratories or Electrical Testing Laboratories or ESL listings. These certifications indicate that the UPS has been tested and meets safety standards. Always choose a UPS that has been certified by a reputable testing laboratory. Also, consider the physical size and form factor of the UPS. UPS systems are available in various sizes and form factors, including rack mount tower and wall mount models. Choose a UPS that fits the available space and meets the installation requirements. Rack mount UPS systems are designed to be installed in standard equipment racks, while tower UPS systems are freestanding units. Wall mount UPS systems can be mounted on a wall to save space. Regarding wiring considerations, hardwired UPS systems require careful attention to wiring and electrical connections. Use appropriately sized wiring and follow all applicable electrical codes and regulations. Improper wiring can result in overheating, electrical shock, or fire. All connections must be made by a qualified electrician. Ensure that the UPS is properly grounded to prevent electrical hazards. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. The grounding conductor should be connected to a grounding electrode system, such as a ground rod or a metal water pipe. Overcurrent protection is another important aspect. Install circuit breakers or fuses in the UPS circuits to protect against overcurrent conditions. The circuit breakers or fuses should be sized appropriately for the wiring and the load. Overcurrent protection devices should comply with applicable standards such as the National Electrical Code, or NEC. Surge protection is crucial for protecting sensitive equipment from voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical event. Install surge protection devices, or SPDs, at the panel board and at the individual outlets to protect against voltage surges. The SPD should be rated for the appropriate voltage and surge current. Furthermore, proper ventilation is essential for preventing overheating. UPS systems generate heat during operation. Ensure that the UPS is installed in a well-ventilated area to prevent overheating. Overheating can reduce the life of the UPS and may cause it to fail. Do not block the vents on the UPS. If necessary, provide additional cooling, such as a fan, to keep the UPS cool. Regular maintenance is necessary for ensuring reliable operation. Perform regular maintenance on the UPS to ensure that it is operating correctly. This may include inspecting the batteries, checking the wiring connections, and cleaning the UPS. Replace the batteries as needed, typically every 3 to 5 years. Keep a log of maintenance activities. Battery replacement is a key maintenance task. The batteries in a UPS system have a limited lifespan and need to be replaced periodically. The battery life depends on the type of battery, the operating temperature, and the number of charge-discharge cycles. Replace the batteries according to the manufacturer's recommendations. Use only the recommended type of battery. Disposal of old batteries should be done properly. Dispose of old batteries properly. Batteries contain hazardous materials and should not be disposed of in the trash. Recycle the batteries at a local recycling center. Some UPS manufacturers offer battery recycling programs. Consider the environmental impact of your UPS system. UPS systems consume energy and generate heat. Choose a UPS system that is energy efficient and has a lower environmental impact. Look for UPS systems that are certified by Energy Star. Energy Star certified UPS systems meet strict energy efficiency guidelines. In summary, installing a hardwired UPS system requires careful planning, professional expertise, and adherence to safety regulations. By following these steps and guidelines, you can ensure a safe and reliable installation that provides backup power to your studio equipment during power outages.